In April 2026, the Artemis II mission will ignite its engines at Kennedy Space Center. This flight marks the first time a crewed spacecraft has ventured beyond low Earth orbit since the final Apollo mission in 1972. The crew includes NASA astronauts Reed Wiseman, Victor Glover, and Christina Koch, alongside Jeremy Hansen of the Canadian Space Agency. Hansen's presence highlights a shift toward international synergy, integrating global partners into the core flight team. Artemis II functions as the tactical opening maneuver for a multi-stage plan to establish a permanent human foothold on the lunar surface. The first space race began as a reactive display of national power. When the Soviet Union launched Sputnik in 1957, it signaled a technological capability that the United States felt compelled to match through the rapid development of the Apollo program. Rushing to meet President Kennedy's end-of-decade deadline resulted in significant technical risks. In January 1967, a flash fire during a launch pad test killed the Apollo 1 crew, Gus Grissom, Ed White, and Roger Chaffee, inside their command module. This tragedy forced a systemic overhaul of NASA's safety and engineering standards. The forensic investigation led to hundreds of design changes, including a redesigned hatch and fire-resistant materials, which allowed the program to proceed toward a successful lunar landing. Once Apollo 11 achieved the goal of planting a flag and collecting samples, the geopolitical pressure began to fade. Without a clear economic incentive to stay, federal funding for deep space missions collapsed, and the moon was left unvisited for over 50 years. History suggests that scientific exploration alone is difficult to sustain. Without a direct rival or a clear financial return, the motivation to maintain a presence in deep space eventually disappears. To prevent another decades-long retreat, NASA is implementing a phased architecture for a permanent lunar base. This strategy shifts focus from orbital stations to surface infrastructure, aiming for a continuous human presence supported by cargo-capable landing systems and nuclear power modules. This infrastructure is being built through firm fixed-price public-private partnerships. Instead of the government paying for all development costs and guaranteed profits, NASA now pays for specific services, shifting the financial risk of delays onto the commercial providers. Companies like SpaceX and Blue Origin are developing the human landing systems for these missions. These entities are driven by internal goals to lower the cost of space access, creating a marketplace where NASA is just one of many potential customers. The industrial scale of these systems is significant. SpaceX's Starship is designed for high-frequency, reusable flights, capable of delivering heavy infrastructure and large crews to the surface in a single launch. These vehicles provide the foundational supply chain for a space economy that prioritizes long-term resource extraction over temporary national prestige. 61 nations have now signed the Artemis Accords, aligning under a framework of transparent, peaceful cooperation led by the United States. A parallel network led by China and Russia is developing its own base, linking lunar exploration directly to state security and national strategy. These coalitions are competing for control of permanently shadowed regions at the lunar South Pole. These areas contain water ice that can be processed into liquid hydrogen and oxygen. Synthesizing this propellant on the surface allows spacecraft to refuel in low gravity. This makes the moon a vital logistical hub, as it is much more efficient to launch missions toward Mars from a lunar depot than from the surface of the Earth. The moon serves as a strategic high ground and the primary refueling station for the solar system. Future operations will rely on heavy industry. Autonomous machines will drill into the lunar crust to process raw materials, operating for years before the first long-duration human crews arrive. Section 10 of the Artemis Accords explicitly supports the extraction and utilization of these space resources. This establishes the legal framework for a commercial economy, providing the security private companies need to invest in large-scale infrastructure. Whichever coalition successfully establishes these logistical routes and extraction sites will effectively set the operational standards for deep space. Building the hardware is synonymous with writing the law. Artemis II initiates a multi-generational competition where success is defined by the strength of a logistical supply chain rather than the placement of a national flag.